Yeah, hello viewers. Here I am with Fish Cup TalTech 2025 problem 2. And this problem, when I'm posting the video, this is the week 5. Uh, I solved last week itself. And this question having one small, I would say, thinking part. Rest is purely mathematics, which I have realized. So without much ado, let's discuss the problem and we'll see the solution as well. So this question is very much a JEE relevant question because this is a question that is seen by and solved by many students from India, and it is based on the basic concept of kinematics called velocity of approach. Now, in this question, the version that they have presented is three-dimensional, and what we have seen so far in JEE context is mostly two-dimensional problem. So this is the problem of approach in which there are four birds instead of two dimension. They're moving in space, and in the very beginning they are forming a tetrahedron. So we'll see the arrangement in the next page. And now the birds are following each other, and there are many hints given, and problem is also given. So you can give a pause to the video and just watch, just read out the problem. And before you see the solution, you can give it a very honest try. It won't be easy for sure, but it is worth a try. So you can pause the video and try solving it once, and then you can proceed to the solution. Now, here is the diagram. If you have read the question, then I'm sure that you can understand the diagram. It's a tetrahedron, and I have used two different color coding in a way. The path on which the birds are flying is shown by the red color, and the two paths which are like part of the tetrahedron, but differently, it's not traced by any particle. But as the birds will move, these two paths will also shrink because if the birds have to meet each other at one time, at one point, then all dimension must reduce to zero. So now the red line is representing the path traced by the birds, and A is following B, B is following the C is D, and D A. So what you can realize that B and D, so BD line and AC line, they are not part of any bird actually. So they're not just followed by any bird, rather they are shrinking naturally. Now on the right side, I have drawn a triangle comprising of two sides A, B, and BC. And there are two types of angle as you can see clearly. One is theta, which is a angle between the two equal sides A and A, and alpha is the angle between the side A and the yellow line AC. Now the purpose of this triangle is to get the angle, and to get the angle we can use the cosine rule. Easily that will give you the answer. So on the next page you can see I have written the velocity of approach. So the dA by dt, okay. So this you can see that this is the first part, which is the velocity of approach of the bird A and B. So as A and B will move together, let's go back to the previous diagram. As A and B will move together, you can see these two lines and this line, these 2 points. Then the V is along B for A. So A is moving along the B, but B is moving along C. So we need to take the component of B along the line to get the velocity of approach. And if this is V, this is theta, so we can say this must be V cos theta. So now this is V and this is V cos theta. So definitely the approach velocity will be the sum of the two. So this is what I have written here. That the rate at which the length will shrink is equals to the velocity of approach that we can write in this format. Now, similarly, if I go back to the line AC, here the angles are same on both sides. These are same angles. So if I take the component of V along this direction, it is going to be V cos alpha, and this is going to be V cos alpha, and therefore the velocity of approach in this case will be 2V cos alpha, and this will be equal to the rate at which the V will diminish with time. Now, we have the cosine law, which we can apply for the triangle ABC, and we can get both the angles easily. And the next part is use these equations. You have to divide the equation, and this will give you the nice differential equation. So this is the differential equation which we need to solve, and this is the most trickiest part of this problem, which I realize that if you are very pro with mathematics, then definitely it's not a big issue. But those who are in class 11th and 10th or junior classes, because they haven't studied the differential equation, so for them this might be a challenging question. Those who are in class 12th and about to finish this course of mathematics, they must have gone through the differential equation chapter, and therefore I don't think they'll find it to be a difficult step. So indeed, I have tried solving this with the basic knowledge of math which I have. And as you can see, I have taken this as some variable t, and then once you differentiate this, you get something like this after rearranging. So the many steps I have just omitted because I got bored actually, to be honest. And then this is the equation that we had earlier already, in which we just substituted a equals to bt. And once I do this, things are pretty easy. Okay, so now these are the equations that we need. And this t is, sorry, this t I just chose and realized that I should not have used t because t is time here. But this t is not a time. This t is just a random variable which I have taken to solve this question. This is t, not a time. So you can choose any other variable if you wish to. Any symbol, you can choose u, k, lambda, whatever you want to. The next step is pretty much solving this, and once you solve, this will reduce to a very simple differential equation. So this is the differential equation which eventually convert into, and this is totally integrable from the basic, integration methods which you have learned. And from here onwards, you can just solve. If you know basic integration, it won't be difficult, and that will lead to a relation which is t, which is a by b, and this t turns out to be this value. Now this is a by b. Again, as I discussed, this is a by b, not time. So now once we get a and b relation, because now we have a completely written in terms of b, so we have the explicit relation of a in terms of b. So now we can go back to the very first equation of yeah, we will go back to this equation, which is the equation of velocity of approach for the other side, which is diminishing. And once we substitute the value, this turns out to be very simple differential equation and a very easy integration. So this S is the VGT integration is the total distance traveled. And this term is very much standard integration. So any standard textbook of mathematics, even NCERT, can go and find the solution of this equation. And once you substitute the value properly, you will get this answer. So I really enjoyed solving this problem, and I'm sharing the solution. Probably the solution will be released later on, because now we are going to the next part of the problem. So it is the ongoing phase cup, and the many questions yet to come. Today they have released, when I'm recording this video, third question, and you can try other question as well. And I would request all the interested physics enthusiasts to participate in such Olympiads, just to challenge your thinking process. And also, if you involve in such process, there are many things that you can learn which is otherwise not possible. So all the best, and thank you.